So, we're going to talk at the same time as we're talking about differentiation. We are going to talk about a progression of multiplication for kiddos. So in front of you, you have a couple things. And right now, you need this set of cards. And there should be 6 cards, I believe. And what I want you to do is I want you to work with your partners and try to put these in order. Now, I also gave you a piece of paper, though, because I really want you to think about what a picture would look like. So just really quickly, let's do one together so we're all kind of on the same page. So you share a loaf of banana bread with 5 friends, so 6 people are sharing it. So could you draw how you would be cutting up your banana bread just on this first little picture up here? So everybody should have a copy of this. I do have some extras. So you're sharing your loaf of bread with 6 people total, 5 of your friends. And I know it doesn't say this on this card, but I would like you to draw your piece underneath this bar if you could. So where's the piece of banana bread that you're going to eat? Just draw that underneath. So you were sharing it with 6 friends, or 6 people, 5, you were one of the 6. And draw your piece underneath. So you have your regular, your whole loaf, and then you should have your piece. Yeah, oh, so just take one of your pieces and draw under here in the white space. Yeah, not on the new bread. You'll need all of the lines, so awesome. Okay, now, with your piece, a friend comes along later, your neighbor. That pesky neighbor is always late. And you agree to share your piece with your neighbor. Draw the amount of banana bread that your neighbor gets. And you can draw it as a separate amount, right? You're handing out the banana bread. By the way, this is a really hard task for kids because they're never asked to draw fractions separate from the whole and still call it a fraction. It's just a piece. It's a piece. I wouldn't give it a name. It's a piece of banana bread. So you've drawn your piece. You have your friend's piece. Now your task is, what name do you give that? What fractional name do you give that? How big? I just want to hear some answers. How big is my friend's piece? 1/12. Anybody get a different answer? 1/12. Why 1/12?
My piece was 1/6.
Whoa, where's your piece?
My piece is the second one.
This one right here. So like this brought down here, these were the same size. So my piece was 1/6, okay?
And if I take my piece or any of the 6 up above and divide them into halves, I will have 12 pieces. So it makes it 1/12.
And I heard you say something like it was a half of my piece, which was 1/6, so a half of a 6. I don't understand where the 12 is coming from. Can someone tell me, if they think they know what she's saying, where's the 12 in my picture? Yeah.
So we cut one of the, on the top one where there's 6 pieces, we cut that one into half. So then I thought if I cut each of them into half, that's going to give me how many total pieces of that 5 there are.
Oh, so it's really important to figure out how many pieces of this size were in the original banana bread. Okay, and so then I took each one, and I don't have 2 colors today, which is unfortunate. I would use colors. And so I take each of those 6 right here, those 6 pieces that are 1/6 in size, and I have to divide them in half, and so that creates 12 smaller pieces that are 1/12 in size. So a half of that 6 you're going to call as 1/12. Yeah? Okay. This is called distributive reasoning. Algebra teachers would love it if we actually promoted this, right? Why distributive? If I'm thinking about, I have to think about this piece, right? My 1/6 right here, and then I'm taking half of that. But in order to get the size relation, what's your name?
Jamie.
Jamie. Jamie explained Colleen's thinking so perfectly and saying, I had to divide each one of those. I had to figure out how many of those size pieces, those mini pieces were in my whole thing. And so notice I took literally a half of a 6 here, 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 right? I had to do that all the way through. I distributed my cuts through. We talked a little last time that when we use the area model, this gets masked for kids a lot of times because I do something like this and I say a half, or I could break it into 6 to begin with. Let's do that. Ooh, these are going to be bad. Pretend with me. Whew, really bad. And then I do this, right? But what doesn't happen for kids is they don't maintain, oh, each one of those 6 created 2 pieces. So they're not seeing it simultaneously happening because they're working in separate directions. You could probably promote that and stop them and ask them, but when we promote that linear model, more of the tape diagram model, they start to see the distribution of those halves throughout. So we really want to promote distributive thinking for kids. Okay? So this card is really asking kids to take a half of a 6, right? And come up with that it's a 12. By the way, I've done this task with 5th and 6th graders, and they always come up with 1/6, and they always draw the bread correctly, and I would say about half of them can name it, and the other half say it's a half of a 6. Or they come up with some random number. But a lot of kids will say it's a half of a 6, but can't name the size of that piece. It's a really challenging question for them. So what I want you to do is I want you to read through the rest of the cards and imagine some similar things. You might want to sketch it out for yourself to kind of see that distributive reasoning and try to place them in order from easiest to hardest. Easiest to hardest, and have a reason why you think those problems go in that order. Feel free to join another table. So let's talk about what you absolutely think is the hardest problem. That might be the easiest one to identify. What's the hardest one to conceptualize? Yeah. Yeah, right? I mean, what the heck? I don't have the card in front of me, but it's...
You have 11 lines here. I have wrote. Your son needs 4/3 and on for a project.
That's just nonsense. What? I remember this is a problem I took from a conference, and they asked me to do this, and I literally sat back and was like, whoa. Like my brain, right? Because they were asking us to do it in this way specifically, not just, I can multiply and find the answer. You all can, right? We all know how to multiply 11 times 4 and 9 times 3. But we had to support it with a picture, and so they were saying, do this and then draw your piece separately. So we had to draw the 11 ninths, and I was like, ooh, like I have to keep track of the ninths here. And then how would I draw 4/3 of that piece? What the heck am I doing here? It was really, really challenging. Okay, so definitely the hardest, right? How about one of the easiest?
Banana bread.
The banana bread, for sure. I would say that was the easiest. And there's another problem just like the banana bread one. It's slightly different though. The piece of gum. Those are, I would call those almost identical. What's the difference? Okay, so the information is definitely different.
We got 2 fractions.
Yes, this is more difficult because I'm giving them fractions instead of say share it, right? I'm actually not using fractional language here at all. I'm talking about sharing, right? So your friend shares, or you share a loaf of bread. I don't have to know that I'm creating 1/6. So I can actually do this problem with 3rd graders and not know that, they might not know that they're working in fractions until I ask them to name the piece. That would be kind of the problem for them. But yeah, this is an entry in that's really safe for kids. So providing access is how can I get them to do this concept without using a lot of math terminology. Right here, I go right for the fractions, right? I have to recognize 1/4 as a fraction to understand that. I have to understand 1/4 in a picture, right? So it's just slightly more difficult. So sharing language is very accessible in fractions, and then inserting the terminology. Okay, so are there 2 cards or 3 cards left? 3. There's 4? 3, because we already said the 1 was the hardest, right? Okay, so what order did you put the other 3 in? Somebody make an argument.
The strip of 1/6. 3/5 of 1/4.
3/5 of 1/4?
That would be like a third.
I'm hearing some yeses. I'm hearing some also, I could possibly agree with that. I'm not sure yet.
I argued that it was the honey wheat muffins
Yeah?
because the meters can throw them off. They're going to say, I don't understand.
So context could throw them off as opposed to the numbers. Yes.
Yeah, so we said pounds.
Pounds.
You can't, that's not a stress. Whereas meter is length, but pound is weight.
Totally. So in these situations, sharing language, but also context, right? Like I often talk specifically with kids about loaves of bread and bubble tape. They love that stupid bubble tape, right? That they roll out. You got this piece of bubble tape. You're splitting it up. I can do problem after problem after problem about bubble tape because they all do those meter-long bubble tapes. So yeah, but when you start to get into pounds and then you're measuring flour, it doesn't have a shape to it, right? It has the shape of the container. And so I can't really visualize it when you're giving me a strip. So that makes it harder for sure. If we're just focusing on the numbers though and not the context, I did that on purpose because I wanted you to have that kind of internal. Which set of numbers is harder? Is it harder to take 3/5 of 1/4, or is it harder to take 1/4 of 2/5? Talk about that at your tables. Is it harder to take, and I actually have some pictures up here of what you guys were drawing. Is it harder to take 1/4 of 2/5, or is it harder to take 3/5 of 1/4? Conceptually, if you're drawing a picture and trying to figure out what this means. Okay. So who wants to make an argument for one of these pictures? Which one is more challenging, kind of visually to make an argument for? Yeah.
I think that 1/4 of 2/5 is harder because you either have to, one of the ways I was trying to do it was to visualize that 2/5 is my new whole.
Yeah.
And that was kind of hard. Or doing it that way, now it looks like two different fractions, and I'm afraid kids are going to be like, oh, it's 1/4 instead of 2/20. Or
Yeah.
it might be it's 2/8.
Yeah.
The other one, it's easier to take that 1/4 and split it up.
Because you just have that one piece, right? Here, all of a sudden, I have to figure out how I'm going to distribute units of 1/4 through that. And there are multiple ways to do that. And so now keeping track of the whole becomes way more complex to track those wholes. So one way to do 1/4 of 2/5 is to literally take each fifth and make it a fourth, right? A fourth, a fourth, a fourth, a fourth, a fourth. And if I put all of those pieces, or if I do 4, 4, 4, 4, 4, right? That's that distributive reasoning. How many pieces do I make in the whole? I make 20, right? And I did a fourth here and a fourth here, and I'm taking those two little pieces and putting them together. And that's 1/4 of 2/5 as 2/20. But I can conceptualize it like this, and I will tell you tons of kids will do this without having a lot of fraction knowledge. They'll go, oh, here's 2/5. I can make 2 into 4, right? Easy. So now what they're doing is they're creating 1/4 of 2/5, literally creating the 2/5 as its own piece and creating 4 slices of it. The problem comes when you have to name this. Because what do you have to do? You have to keep track of the 2/5. It's another unit now. So I have 2/5 right here. Now I got to do that again with it. See, I did the big piece too. The 2/5 there. Oh, but I only have 1/5 here. So what do I have to do? I just make 2 pieces, not 4 pieces, because it's only 1/5. Right? So I've actually created a picture. So this size is 1/10. Because that's how many pieces I create of that size in my whole. 10 pieces. Oh, look, we have equivalent fractions, right? Which one's right? Is it the same size? If I put those two together, would I get the same size? Now I'm really understanding the difference between 1/10 and 2/20. But it's a really interesting discussion to have. Calculation-wise, we'd always come up with this one, right? Or we might reduce first and do that craziness that we do with kids that they don't really understand. But now I'm justifying it in terms of the size of the piece and inside the whole. And that's really complex. And again, that area model doesn't create that discussion for you. So these are the first models you would use. Later you can use the area model, but really focus on getting them to distribute those units throughout. How can you get them to think about, I'm creating pieces here, I'm creating pieces here, I'm creating pieces here? Because in the real world, when we take fractions of fractions, that's what we're doing. We're taking pieces and pieces and pieces and creating new wholes and equivalent parts. So when we do this, I'm just keeping track of one. So when we take a unit fraction, a non-unit fraction of a unit fraction is easier conceptually than a unit fraction of a non-unit. I have this on the slide so you don't have to write it down. So just so you know. If we were just teaching computation, they're the same, right? I multiply across the top and the bottom. But if I'm really understanding what's going on in my picture and keeping track of those units, by the way, I know this seems really challenging, but the more we force kids to keep track of units, the better prepared they are for algebra. Because that's what algebra is distributing units and changing units into equivalent units and moving them around when they're not numbers, when they're variables, right? If I'm thinking about that factoring that I did when I was in high school, and they made me do these things, I had to factor it and I had to FOIL it, I was changing the same thing into different units. But those units were not defined, they were defined by a variable, and I could change what that unit looked like. So having them keep track of that unit gets really messy, and they will call it 2/8, or they'll call it something wrong, and that's where we have to really focus our discussions. Okay, so you guys nailed it. So the easiest, and again, this is in my slides, which I think you all have access to. I'll make sure it's in the Google Classroom. Unit fractions of unit fractions are the easiest problems for kids conceptually to understand. And in fact, these are problems, sharing problems, actually promote the idea of equivalent fractions. So when you start to think about a fourth of a third, you can actually ask kids, how would you make your thirds into fourths, each piece? You don't have to take a fourth of 1/3, you could take a fourth of 3/3, if that makes sense. So then they see where the 12 comes from. Oh, because I created 4 parts here, I created 4 parts here, I created 4 parts here, and I created 4 parts here. Then you move into those equivalent parts there and making equivalent fractions. But that distributive reasoning significantly impacts their ability to make equivalent fractions. Can they actually see the parts being divided? So you don't have to call it multiplication in 4th grade when they're doing those equivalent fractions. You can just ask them to find those pieces. So how would you split your 3/3 into 4ths in each section? You can even ask them, how would you make them 12ths? What would you have to do? So they start to understand I'm slicing each piece into the same amount. Okay. Non-unit fractions of unit fractions, and this seems backwards to our logic. We would think unit of non-unit, but non-unit fractions of unit fractions, which are the 3/5 of 1/4, are the next easiest because you're only tracking one piece. And then you complexify it again by the unit fraction of the non-unit fraction, and then the last one would be the generalization, the fraction of the fraction, and you had 2 of those. You had 4/5 and 3/4, and then you had 11/9 and 4/3. Obviously, the 11/9 is much more difficult when you're trying to conceptualize a picture in that. And we often don't ask kids to draw pictures at that point. They already have the process, and so they just do it. But it's real. It actually happens. So this is the order of progression of difficulty. So one of the ways that you can differentiate your classroom, whether you're talking about fractions or multiplication or division, is think about number choice. How can I have everyone enter into this concept with simple numbers so we can focus on the concept? And then how do I get more complex and more complex and more complex? How do I build off of my number choices and make them more complex? Your resources often do not do this. They just put numbers in because you're usually computing and you're focused on a process. So literally these all have the same difficulty if I'm just using the process of multiplying across the top and the bottom. But when I'm conceptualizing it, it's significantly different. So think about what number choices are simpler and help me access the concept, and then I can build complexity from there. So that's one way that you can differentiate your classrooms. A second way is to use multiple representations, which we have done all the way through this workshop, but also using worked examples. So I want to give you an opportunity. So first of all, we used worked examples up here a little bit. I did most of the processing because just for time's sake. But this is an example of worked examples. I put up a diagram and I asked you to make sense of it. That's what we do with worked examples. So interestingly enough, they did research on worked examples and algebra. And they gave kids, so they had 2 different classes, and they gave kids a whole period of time where they were doing kind of traditional, you do your own problems, you do your 30 problems, I don't know, the odd, whatever, blah, blah, blah. And then this class didn't do that. They actually they substituted that practice time by looking at worked examples and giving explanations for those worked examples. Sometimes they had errors in them, and other times they didn't have errors. So they didn't always have to explain something that was wrong. You've all seen the MSET problems that are like that, right? They're very challenging. What they found was the kids who were in this class doing the worked examples had a stronger conceptual understanding, and they had the same procedural fluency as the other group. So they didn't do 30 problems ever, but they got the same procedural fluency as the other group because they had to constantly explain those worked examples. So that's a way, right? If you have 20 problems, how could we take a couple problems, work them out for kids, and the whole exercise is them explaining the work and talking about the work and what's going on, changing the work. Here's an example of, here's the work for a fourth of 2/5. You have to justify both of these in the picture. Go, right? I didn't do that work. I didn't come up with the picture. Sometimes we use this when we know kids are going to come up with the wrong picture. Here's the right picture, explain it. I don't want you to go to the wrong answer today. I want you to go to the right idea and right concept, and I want you to explain that. So there's a lot of power in that. So here's an example of that with fractions. There's a video of this, which is fantastic, in a 4th grade classroom. It's on the teaching channel. I didn't make this. This comes right from the teaching channel. You needed a couple extra copies? It's a great lesson to watch. You get to watch kids collaborate around this. And so I'm going to give you a couple minutes. I actually want you to work out the math in this. I have some extra copies if you want to take a blank copy with you if you're interested in this lesson. So here's an example of worked out examples. And it's also an example of multiple representations. Because if you look at this diagram here, multiple representations are visual, symbolic, verbal, contextual, and physical. We often think about, oh, you got to give them the picture first and then you work to the symbolic. But if you notice, really thinking hard about mathematics and understanding it is being able to translate among those representations and going back and forth. So we don't always start with the symbols. Sometimes we can start with the symbols and then translate it to the picture. But the idea of, do they really understand this? I wonder if they can understand this with a model. I wonder if they can put this into words. Right? I can test 3rd graders on multiplication knowledge, and then I ask them, and they all know their fluency, they got it, and then I say, can you give me a story for that? Whoa, very different. Especially when you give them division. Whoa, you should hear the stories they come up with for division. Yeah, you got the answer, you're right. You know what 27 divided by 9 is, but you sure can't tell me a story about it. So what good is that knowledge? So thinking about how can I get them to translate among those representations. Again, your books largely start with pictures and then moving to calculations really quickly. So how can you get them to play, right? I'm always asking you, how can you explain this inside of this? Or how can you take this and get to this, right? So I'm asking you to go back and forth between that pictorial and that symbolic. Also verbal because you're explaining to your peers. So this is the Shamrock Smile Mile. I want you to go through and put checks beside the representations that are accurate for the problem 2/3 of 3/4. Oh, you need the story though. The story is you run a mile, or you run 3/4 of a mile. This is in, I didn't even know the story. So you run 3/4 of a mile, and you are going to stop at the marker 2/3 of the 3/4. Which picture represents that? And why? So not just which picture represents 2/3 of 3/4. Which one represents 2/3 of 3/4 of a mile? and why.
Are you making little videos of yourself and putting them on YouTube for us to watch?
No, because
You should.
it's really hard to do that because I work in different districts, and so to have permissions in every district, that's the challenge. You guys need to make the videos so we can watch them. You can watch this one, but it's not with students.
You go back to your daily life, you know?
Yeah.
What, do you find a certain curriculum that you like?
Oh.
Teaching fractions?
With teaching fractions? That's a good question. There are certain curriculums I like better than others, but that's probably a personal preference more than. There are some that I feel like lock us into part holes, and that's really challenging. Yeah.
I mean, we're doing a 5-year review.
Yeah. What do you guys currently use? Oh. Yeah. If your teachers like the idea of the tasks, though, more complete curriculums exist, like bridges and investigations that are like that. Okay, let's just talk about it because math is fun. Which pictures are a representation of, let's start with this. Which pictures are a representation of 2/3 of 3/4? 1, and 3 and 4. I heard all of them.
We're looking at the pictures.
Okay, so the pictures, so they look really different though, right? So even that's an interesting discussion, right? How can the first one represent the same thing as the second one, which was kind of this discussion that we had up here, right? Distributing versus, oh, there's already 2 parts there. I don't have to do that. Good. How about coming up with the correct number part of the mile that you would stop at? So which one do they all have the correct ones? No. Which one's? The second one's incorrect, right? But you can totally see where they get it, right? What happens?
They forgot to distribute on that.
Yeah, they lose the whole, right? That's what's so tricky about fractions is they're actually operating with 3 units at the same time. So they have to keep track of the whole, which was never part of the problem, right? You were on a track that was 3/4 of a mile. So the mile was the unit that they had to keep in mind. Then you have a 1/4, and then you're finding 2/3 of that 1/4. And then there were 3 of those 4ths. So it gets really messy for kids. So they lose track, for sure. That's what the interesting conversations are about. But you can see the pictures, so having the conversation about 2 and 3 in terms of the pictures. But I would argue that not all of these pictures represent my story. If I'm on a 3/4, and I did put the actual story up. Well, I put the lesson plan up. You just can't see the story. I'll show you where to get this lesson plan. And watch the video. There is a video to this. The story is, if you're on this 3/4 of a mile track and you want to stop 2/3 of the way, which pictures don't represent that? Even though the picture actually might give you the right total, or the right fraction, which picture doesn't actually represent my story?
The last one.
The last one, why?
Well, we had a conversation. I said I didn't understand this one until she said this is more when we talked about cakes and brownies.
Yeah.
And I went, oh yeah, that was okay.
So this story would match a cake and brownie problem, totally. And lots of us have taught out of programs that have used cake and brownies for multiplication of fractions, right? So this matches that, and it's a great context for that. But for this story, it doesn't really match because I'm going around a track, right? And here I'm cross-dividing.
I would say that 2 and 3 don't really match the story either.
Yeah.
Because you don't start and stop and start and stop.
Yes.
That wasn't my story. My story was I'm going to stop at 2/3 of 3/4, right? And so now I'm really having to think about that continuation of
The
it.
middle one I was saying looks like you ran, got a ride, and then ran.
You stopped every 2/3 of a 1/4 of a mile there, right? Yeah.
Carried you.
Yeah, exactly. And so the calculations for those, right? So you're actually finding 2/3 of a 1/4, and then 2/3 of a fourth, and then 2/3 of a fourth, and then those other pieces you're getting carried or riding in a car versus the 2/3, the continuation of that. So really interesting discussions that you can have over this, and we're giving access because we're giving kids the worked out pictures, right? I don't have to create the picture. Sometimes I can't create the picture at this point. Sometimes I need the picture to start with a couple times, and then I can create my own. But what I don't need is someone giving me step-by-step how to create the picture, right? You put the picture in front of them. It's not magic. They interpret it. That's what models of mathematics are about, is the student's interpretation of them. So often, I will put up pictures, right? This is the greatest thing to do when you don't have, you guys have had how many, you had February off, 11 days off, right? And you feel time crunched and you're like, they don't have time to investigate this. So put up the picture and have them talk about the picture. It's a great shortcut. We don't always want to do that, right? Kids do need to create these things at some point, but they will get understanding as long, and the research is very clear on this, that they did in those algebra classrooms, is the students are doing the self-talk, not the teacher. So the students are interpreting the picture. And so you have to spend the time on interpretation. So I don't understand, right? I asked you that question. I don't understand where, it was the other picture. Where's the 12? That doesn't make sense to me. It's not on my picture. Show me that, draw me that, tell me that. Explain it to my neighbor. Having kids explain it to the whole class, but then also having them, okay, so they just said something really important. Tell your neighbor what they said. And then a couple other people are going to come up and explain that same thing. That's self-talk as well. It's not coming from the teacher. It's coming from our classmates. They have to paraphrase it. They have to put it in their own language. They have to miss parts of it. We have to correct each other. And that's the development of language that we work on in the classrooms. What's interesting is as they work on these worked examples together, they're going to use really informal language, this and that part, because they can point to it. But when you start to have discussions here, we now have a need for mathematical vocabulary. So they're going to practice and they're going to say this and that. Wait, what do you mean this? What this are you talking about? And then you can put those language in. And then, okay, I want you to explain to your partner, but I want you to not use the word this. You have to use the names of the parts, the fraction names. Ready, go. And so you're practicing language with them before they ever have to write it. I was just in a district yesterday, and they were like, we do all kinds of explaining at the number corner. And I said, well, how many kids? But then they took their number corner assessment, and none of the kids could explain multi-step word problems. And I said, well, how many kids explain? Well, the kid's strategy, right? And then the other kids listen to it. Oh, so everybody else needs an opportunity to explain as well. So is everyone getting an opportunity to explain a strategy? It doesn't have to be their own. It could be the focus strategy, right? So you're strategically putting work up on the board and ideas up on the board. They did this problem. And I'm going to credit them with this problem because I wanted 1/10 to come up. And then someone else over here did 2/20 and drew this picture. So I'm going to put this one up and we're going to talk about it. But I'm going to make you talk about their ideas. And that's really tough for kids to do at first. It's really important for us to be able to explain each other's thinking. So we're going to take the time to do that. Tell your partner, oh, we need to clarify it again. So tell your partner. And it will take a lot of time at the beginning. The more you ask them to do that, the better they're going to get at that. All right. So the two ways, oh, I want to show you where this is. So if you go to the teachingchannel.org, this lesson is called A Passion for Fractions. It is worth watching. It is a really, really nice lesson enacted with kids, and you can watch the teacher questioning students, kids working in small groups, and then doing a whole group discussion. So it's called A Passion for Fractions. If you've never gone to the teaching channel, you can just watch the video, but often they have supporting materials. So under supporting materials, they will make you create a free login with whatever email you want. But as soon as you log in, now you can actually download the lesson plan, which is what was on the board. This is the worksheet that I printed for you. So they created that there. And then some questions, a mathematician's questions. I think these are the questions that she asked the students. Oh, it just downloaded it. Let's see if we can open it. Nope, I just downloaded it 3 times. Let's see. Yeah, so it looks like her reflection questions at the end. So at the end, what new knowledge have I learned? What helped me in the process? What slowed me down? What are some other situations I might apply? So that was her reflection part of the lesson. So just supporting materials, if you want to do that, you have to log in. All right, so the 2 ways that you can differentiate any curriculum is think about number choice and think about multiple representations and using worked examples. How can I get kids to explain someone else's work? And start with correct work, because it feels safe for kids. It feels safe for you. I'm telling you this is the right answer. Your job is to explain it. It also takes that pressure from kids that they have to explain their own work and they're not sure, right? I take the pressure right away. This is correct. You just have to figure out how to explain it. Now I'm in a completely different mindset in the classroom as opposed to I always get the wrong answer and I don't want to share because my answer is wrong. And then you can move to explaining incorrect work. Eventually it will become their work in the class, right? Like I want to talk about 2 examples in this class and let's talk about how are they the same, how are they different. Really powerful for them, but really making sure that we're not just talking about calculations. We often only focus on one representation and we don't go between them. So how can I use a context, right, and link it to the symbolic? Often we do that with word problems. Word problems are hard, but do you ever ask them to take the symbolic and tell me a story for it? And then create a visual. Or what about a physical object that they could manipulate? All right. So as we head into the time that we're going to collaborate with each other, here's a quote. We're going to give you some time. You can process whatever you want. I'm not going to tell you what you're going to talk about in your critical friends group. So this is really support. You have some new ideas from today. You've had some ideas from before. You've tried some things in your class. I want you to think about what you've already tried and even maybe what we've learned today. And what you're going to do is you're going to get into trios. And oh, it worked out. We have exactly trios. That's amazing. And what you're going to do is you're going to define someone to be an A, a B, and a C, okay? And A is going to share evidence or something that they're thinking about in their class. Notice it says no crosstalk. So that person A gets to talk. It's 6 minutes. Hopefully they won't talk the whole 6 minutes. But they get to share what they're working on and some questions that are bubbling up for them. The rest of the group is going to respond to that. I'm thinking, right? Try to put out a warm, like, ooh, I really like this. That's making me think. And I wonder after that. I would encourage you to go around and share out the I likes and then share out the I wonders. Then person A, after everything gets shared, so you're not sharing one at a time, then person A is going to respond to that. You do not have to respond to every comment because the great thing about this is when you get feedback from 2 other people, they're going to point out 2 things that they like and 2 things that they wonder about. And you're going to grab onto something on that. It's going to make you think deeper about that. Oh, hadn't thought about that. Or yeah, I was feeling really insecure about that. And you liked that part. So I'm feeling good about that now. Right? So that's what that time is for. It feels awkward because you want to talk. Because that's what we do as colleagues is we talk to each other. But it really makes you sit back and listen to the feedback and listen to how other people perceive what you're doing. And then person A, you're going to share, like, what am I going to do next with this based on what we did. So it's going to take 6 minutes per person. Not a lot of pressure. You don't have to produce a lesson plan. If you have pictures, great. If you want to just describe what you're doing, that's fine too.